Everyone, welcome to learn the algorithm with me together. Today let's take a look at 5 to 5 contiguous array. And now we will be given a binary numbers and then return the maximum length of a contiguous subarray with an equal number of 0 and 1. And first of all, we have to know what is binary array. Binary array means like we only have 0 or 1 in this array. And then the subarray, the contiguous subarray means that all these numbers should be neighbors one by one, and we never skipped any numbers in the subarray. Or probably we can use an example to understand this. Like we have these numbers like 0, 1, 0, 0, 1, 0, 1, or probably we can have 1, 0, something like this. And let's also add the index so that we are easy to know like which position I'm talking about. Like we have 0, 1, 2, 3, 4, 5, 6. All right, and this is index. And the subarray means like we have to have a contiguous numbers, like from here to here, like from the position 0, 2 to 4. Now we have 2 0 here and only 1 1. It means that the number of them are not equals. So this is not the subarray we want. And what about like we expand this subarray like from to the left? Now we have like 4 numbers and 2 1 and 2 zeros. So now their number of the 0 and the number of 1, they are equals. So now this is the subarray we want. And the length of it is 4, but it's not the maximum, right? And like if we continue to extend like from 0 to 5, now we have like 3 0 and 3 1s here, and they are still balanced, and it means that we have the maximum length is 6, and we can return 6 as the answer. And how we can solve this problem? First of all, I will definitely think about like just use the brute force way to traverse the whole array using 2 pointers. Like one pointer means like starting point, right? And another pointer means like the ending point. So for example, like from here, when we are have the window of here, we can use another pointers to help us to like calculate how many 0 and 1 here, right? Right here we can use a counter to help us to count like how many numbers, not how many 0 or 1 here. So the whole time complexity is like, first we have used 2 pointers, it will cost us like on squares. When we are adding another loop, it means like on n squares have 2 times on again. So it means like we will have like on triple. So it will cost us a lot of time. It's inefficient, and now I'm wondering like how we can make it more efficient, right? So here like how we, first of all, when we are using like this red pointer, help us to count how many 0 and 1 here. Sometimes we are just using like a variable, like 1 counts equals to how many numbers are 2 counts, a 0 counts, 0 number count is how many numbers, right? use two variables to help us to keep track of it will be inefficient. Like I'm thinking about when we are if we meet 0, we can treat it as -1. So for example, like if we have the sum here, 0 equals to 0 at starting from the beginning, and then we start to loop the array. Now if we meet 0, we start to, then we add the sum as -1. Else, if we meet 1, then the sum will add as 1. So it means that here, when we see 0 is -1, when we add 1, it equals to 0. So this sum is 0. It means that if the sum equals to 0, means the subarray is already balanced. Right? They have the same 0 and same 1. Like when we continue to move forward, we have one more 0. Now the subarray is the sum will be -1, and add one more 0 -1, and at this like one more 1 is -2, -1 here. All right, and so when the sum is 0, means the array balance. This is first thing I can think about how to make it more easy, not use like two variable to count it. And after that, when we are talking about, we have the contiguous subarray and we calculate the sum. Here we have to mention about a technique called PrefixSum Technique. Usually the PrefixSum Technique will help us to calculate the sum of the subarray. And how does it work? Let me talk about this technique. For example, like we also have numbers like 2, 4, 1, 5, 3, like this in the array. And also let's get the index here. All right, and now PrefixSum means that prefix is from the starting point to, the beginning of the array, till the pointers point to the current position. So this is a prefix, like this. This is prefix. So the prefix sum from the index 0 to 1 is 6, or the prefix here is 7, right? And if we got this prefix sum, for example, now we want to get like for the position 2 to 3, this subarray, what is sum? What is the sum of this subarray? And probably we can like get the prefix sum of from the 0 to 5, and then subtract the 0 to 1, this subarray, right? Like if we can calculate the prefix sum, like this is 2, 6, and how we got 6 is like add the previous prefix sum at the current number, like 4, right? And now when we are moved to the position 2, we got the prefix sum is like the 6, add one more 1, here is 7, and 7 plus 5 equals to 12, and 12 plus 3 is 15, right? And now we want to get like the position 2 to 5, so we can get the prefix sum to the position 3 is 12. 12 subtract the position, the prefix sum position 1 here is 6. 12 subtract 6 equals to 6. 6 is what we want to know. Like here we can point out 12 subtract 6 equal to 6, and 6 is what we want to get the sum of the subarray. So now how this technique to help us for the current problem. Let's go back to the current problem, right? And now when we are using a pointer point to here, like we already got its current like PrefixSum, and how do we know like for like this the subarray PrefixSum, we can know like we can get the PrefixSum from the position 4 to subtract the PrefixSum as the position 1, and once we subtract them, we got the sum. For example, now like here is like -1. It means that the number of the 0 and 1 in this subarrays are unequal. But now what if like from here, so we also can get the PrefixSum from the position 4 and to subtract the PrefixSum from the position 0. So now probably like it's definitely like the sum of these subarrays equals to 0. So it means that we have balanced number, balanced 0, 0 and 1. And now we already know the sum of the subarray is 0, but how we know how many numbers here? So here means we have to know the index, right? Because we only know the PrefixSum, but we don't know the index. So we have to get the index and then to calculate the length of this subarray. So now we definitely to have a map instead of just a PrefixSum array, right? Why we need a map? This map will look like we have the key and value, and what's the key? And the key is, this is the brute force. Let's move to here. The key can be the PrefixSum, and the value could be the index. So that one we are get the current PrefixSum here is, for example, is -1, and we can check the map to see if the there's another same number of the current PrefixSum. If they have, it means that when we are subtract these two PrefixSum, the subarray between them equals to 1, right? Probably we can write it down, right? If current PrefixSum equals to like any, like if the map contains current PrefixSum, it means the subarray, the sum of subarray is 0. So they are balanced, right? You can use these two this is the same thing, right? And if the sum of the subarray is 0, and if the sum equals to 0, means the array balanced, or we can say subarray balanced here, right? So now let's make it like more clear to understand. Like, for example, we are starting from here. The prefix sum is like -1 here, and the index zero. And the next is the prefix sum move to next position is 0. Because -1 add 1 is equal to 0, but the index is already 1. And now we move to next position. So now we are adding, when we meet 0, we add -1. So 0 at -1 equals to -1. And now we can see that we have the same prefix sum. So it means that when we are subtract them, we will got this from the index 1 to 2, and now we only have like 2 numbers, and we have 1 1 and 1 0, so they are balanced, and we can get the length is current index, like then current length equals to like current index minus 2 previous index, right? So like, for example, you can get from this map to get the key, like current prefix sum number. So we can also get the index there. But now I'm thinking, like, now because we have the same key, right? Do we need to update the index? Probably we don't, because when we are like this, oh yeah, so now when we are to position 2, it means right here, yeah. Probably we don't want to, for example, like this. When we are moving to here, we are probably have the like -1 as well. But because we want to have the maximum length of the subarray, not the shortest one, so we don't want to update the index, so that when we are seeing the -1 again, probably we can continue to like calculate from like the beginning, right? Because when we are, if we are going back to 0, and then we will have another -1 from like the position 2, we don't want to calculate only from the 2 to 5. We want to calculate like the first -1 coming out, right? So this is the maximum length. So we don't want to like update. So if the map already contains this prefix sum, we don't update the index. But if we never made the prefix sum before, right? So if the map doesn't contain prefix sum, we will add this prefix sum and the index into the map. Yeah, so this is what we want to like get, because got the maximum. So we don't care about the latest index. Now, this thing, the whole idea is how I solve this problem. Like, of course, this sum is not only called sum. We can just say it's PrefixSum. So when we make 0, we then add -1. If we make 1, we add it as 1. And then we check the map if we already have the PrefixSum before. And of course, there are some current case. And what is the current case when we are using the PrefixSum technique? Is that, for example, in this example, if the starting is 0, and then when we are moved to here, 1, we already got the PrefixSum is 0, right? Actually, till now, we should already have the balanced 0 and 1. But when we are check the map, how can we tell this? We don't know that. So it means that we definitely have to add one more PrefixSum, like 0 here, before we are starting the starting to traversal the map. We will have to add one more, like 0. Why we need to do that? 0, and the index we can set it as -1, so that when we are like this, when we are coming to this position, we already get PrefixSum 0 again. It means at index 1, we already we also have the balance number, so we got the previous index like -1. So current index 1, subtract the -1, we also get the length of 2. So that will help us to don't miss the first letter of the array. This is the tricky part. And now I think this is how I think to solve this problem. Let's do the coding according to this pseudocode. All right, and let's move to here. And first of all, we need to initialize a PrefixSum dictionary and use integer as the key and value. We can say it's PrefixSum to index map, new hash map. Right, let's move to here. And of course, as I say, for the current case, we have to put the 0 and -1 first, so that we won't miss the first number in the array. And then we can start to initialize a PrefixSum at 0, and we start to loop the numbers in the array. Of course, we need the index. We use the I, starting from 0. And first of all, you can see the PrefixSum will be at what? At the, if the current numbers we see equals to 0, we will add -1. Else, if it's not 0, we are at only 1. This is how we calculate. And then if the map contains the current PrefixSum, we can calculate the length. Of course, we have to use a max length to keep track of it, like 0. We're starting from 0, or probably I'm thinking, is it possible that like the whole array will only have 0? If only have 0, it means that the longest one is, yeah, it's still 0, it means that we don't find any subarray that have the balance 0 and 1, so just return 0. But now if we already have 1, we can calculate like current length is equal current index minus the like that get the starting index is PrefixSum, and then we update the max length using the max and current. Alright, so if it doesn't like have the same PrefixSum, we can just update the map PrefixSum and index, and finally we can just return the max length. So this is how I do. Let's run it. Oh, here contains key, probably it's not, it's put. Alright, so this simple case of definitely can be passed, but let's update to some like we all have 0. How does it look? Okay, good. And other okay, cool. And what about like if we only have one number? Okay, so now everything passed. Let's submit it. Yes, it's accepted and not bad. So this is the whole steps what we can do, and the left side is the codes and the right side is like our pseudocodes. That's how we solve this problem. Usually we can have the idea with the pseudocodes and then convert the pseudocodes into the real codes. And also from this problem, we already learned about what is PrefixSum technique. And this PrefixSum technique usually helps us to solve the problem like we get the sum of the subarray, or the sum of subarrays equals to like k, or probably we can have a lot more problems later. Yeah, so hope you can learn something here, and thanks for watching.